Hi folks, we're going to take a look at 18b from page 357. So the equation that's given here relates the number assigned to a particular protective eyewear compared to the fraction of light which it transmits. Okay, so T represents the fraction of light that that particular eyewear transmits, and here we want to know what fraction of light is transmitted by a number 14 piece of protective eyewear. So essentially we're solving for T in this question here. Okay, so let's replace N by 14. Okay, and we want to solve for T, which gives us that fraction we're looking for. Okay, now notice that our variable is inside a logarithmic expression, so in order to remove it from a logarithmic expression we should be expecting to use an exponential function at some point. Okay, but we can't do that directly from the equation that's given here. First we're going to have to isolate log of T. Okay, so again, a couple ways you can do this. Since this is negative, I'm going to bring this over to the left hand side of the equation to make it positive. So 7 log T over 3, and then I'll take the 14 and bring it to the right. So 1 minus 14 is negative 13. Okay, and now I can easily isolate log of T. So I'll multiply the 3 to the right hand side and I'll divide the 7. So negative 13 times 3 divided by 7. So that gives me log of T equals negative 39 over 7. Okay, now I have it in a friendlier form. So now I can take this equation with this logarithmic expression and turn it into one with an exponential expression. Okay, so we know that this is log base 10. So this means base 10 to the exponent negative 39 over 7 is equal to the input of the logarithm, which in this case here is T. Okay, so we've essentially answered the question. This is the fraction of light which goes through this particular eyewear. Okay, however, this is not it's not a particularly obvious number to work with, so let's actually estimate that. Okay, and since this is an application type question, the assumption is that you will estimate here. Okay, so let's take 10 to the exponent of negative 39 divided by 7. And we've got an extremely small number. Okay, so here T is 0. That looks like 1, 2, 3, 4, 5 zeros, and say 27. Okay, so this is what portion of the light it gets transmitted through that particular eyewear. So if we want to write this as a fraction, okay, as it's requested, so this is 27 over 10, 100, 1,000, 10,000, 100,000, million, 10 million. So this is 27 10 millionths of the light that originally enters the eyewear. That's what actually goes through. Okay, so clearly number 14 is when the intensity of light is very, very strong and you need to eliminate most of it. Okay, so that's it for this problem here.